For this question, you must show all of your working out and calculator methods are not allowed. So 5a or 5i, solve by factorising the equation 2x squared minus x minus 3 equals to 0. So let's factorise. We're going to have a 2x times an x to get the 2x squared. We're going to have a minus 3 and a plus 1 so that we get the minus 3. So let's just double check that to make sure this is correct. We've got 2x times x gives the 2x squared. That works. We've got the minus 3 times the 1 to give minus 3. That works. But most importantly, we need to make sure we get the minus x in the middle. So let's check that. We've got 2x times 1, which is 2x. And when we combine that with the minus 3x, 2x minus 3x is minus x. That does work. So now we've factorised that, we can make that equal to 0. And now I can see from here that one solution is that x is equal to 3 over 2. And then from here I can see that x could be equal to minus 1. So those are my answers for part I. Part II, I need to sketch the graph. So let's draw a little set of axes here. Here's my y-axis, here's my x-axis. Right, I can see that it's got a y-intercept of minus 3. And I worked out in part I of the question that it has roots at minus 1 and at 3 over 2, or 1.5. So therefore, it's going to look like this. So that's my sketch. I could work out the equation of the turning point here if I needed to by completing the square, but the question's not asked me to do that. So I'm just going to do that with the roots and the intercepts marked on. So that's I. Right, part I. We need to show that this equation has no real roots. Well, it will have no real roots if the discriminant b squared minus 4ac is less than 0. So let's check that. The a is 1, the b is minus 5, and the c is 10. So a is 1, b is minus 5, c is 10. So substituting each of those into the discriminant to see if we get something that's less than 0. So we've got minus 5, that's the b squared, minus 4 times a times c, which is 25 minus 40, which is minus 15, which is less than 0, therefore no real roots. And then part 4. We need to find the x-coordinates of the points of intersection of the graphs of y equals 2x squared minus x minus 3 and y equals x squared minus 5x plus 10. We need to give our answers in this form. So, intersection. We're thinking simultaneous equations. They're going to intersect when they have the same axes, same coordinates. So if I take the 2x squared minus x minus 3 and make that equal to the x squared minus 5x plus 10, because that's where they have the same y coordinates, take the x squared off both sides, add 5x to both sides, and subtract the 10 from both sides. Okay, I need to solve this equation. It's not going to factorise, and I'm not allowed to use calculator methods. So instead, I'm going to complete the square. So we're going to half the 4. We're going to take away 2 squared, which is 4. And then don't forget the minus 13. We're going to simplify. And now we're going to rearrange to make x the subject. So I'm going to add the 17 to both sides. I'm then going to square root. So when I square root, I get plus or minus root 17. Now take away the 2 from both sides. So x is minus 2 plus root 17 or minus 2 minus root 17. And these are the x coordinates of where these two graphs would intersect.